Hello students, welcome back to the next module. Students, in this module we are going to solve numericals on kinetic energy, potential energy and total energy. So let's start with important formula. To begin with, kinetic energy is half k a square minus x square. Since k is m omega square, we can also write it as half m omega square a square minus x square. At mean position, we know kinetic energy is maximum with the formula half k a square or half m omega square a square. At extreme position, kinetic energy is 0. Let's see the next formula, potential energy. Potential energy at any distance x is given by the formula half k x square, which can also be written as half m omega square x square. At mean position, potential energy is 0, and at extreme position it is maximum with the formula half k a square or half m omega square a square. Total energy at every point remains the same with the formula half k a square or half m omega square a square. Total energy in terms of frequency f can also be written as total energy is equal to 2 pi square m f square a square, or in terms of time period it becomes 2 pi square m a square upon t square. Remember students, the magnitude of potential energy max and Ke max is same as of total energy. We will be using this concept in some of the numericals and MCQs. So let's start with the first question. An object of mass 0.5 kg performs SHM with force constant 10, amplitude 3. We have to find total energy, maximum speed at x is equal to 2, and potential and kinetic energy as x is equal to 2 centimeter. So to begin with, first given is mass 0.5 kg, m is equal to 0.5, force constant k is 10, and amplitude is 3 centimeter, which is 3 into 10 raised to minus 2 meters. Also we can see instantaneous displacement is given as 2, so I will write x is equal to 2, which is x is 2 into 10 raised to minus 2 meters. To find students, the first is total energy, next is V max, maximum speed, next is instantaneous velocity V at x is equal to 2 centimeter, and also kinetic and potential energies at x is equal to 2 centimeter. Let's see the respective formula students. The first term, total energy, the formula is half k a square. In this case, since k is given, this will be a better formula to solve total energy. The next term, Vmax is A omega, but omega is not given, hence I have also to use the formula omega is root k by m. The next term, instantaneous velocity, V is omega root a square minus x square, potential energy is half k x square, and kinetic energy no doubt has its own formula, but since if we find total and potential energy, the better for easy calculation is kinetic energy is total energy minus potential energy. So let's find the first term. Before that, let's find omega first. As we know, omega square is k by m. Let us substitute the respective value, that is 10 upon 0.5, which will be 20. Now taking root on both sides, we get omega as root 20, which is nothing but 4.472 radians per second. Let's start with the first quantity. Students, total energy is half k a square. So let us substitute the respective values. I get half into, that is 10, into the value of amplitude, which is nothing but 3 into 10 raised to minus 2 the whole square. I can cancel 2 and 10, and the next step becomes 5 into 9 into 10 raised to minus 4, which is 45 into 10 raised to minus 4 joules, which can also be written as 0.0045 joules. The next quantity, students, we have to find maximum speed, which is nothing but, yes, A omega. So V max is A omega. Let's substitute the value, that is 3 into 10 raised to minus 2 into 4.472, which on direct multiplication becomes 13.416 into 10 raised to minus 2, also written as V max is equal to 0.1342. meters per second. Instantaneous speed is omega root of a square minus x square. So v is omega root a square minus x square. Let's write down the value. No doubt omega is 4.472, but for easier calculation, I will take it as root 20 into. Let's substitute the value of a and x. That becomes 3 into 10 raised to minus 2 the whole square minus 2 into 10 raised to minus 2 the whole square. So v becomes root 20 into, on squaring the terms we get 9 into 10 raised to minus 4 minus 4 into 10 raised to minus 4. On subtraction this becomes root 20 into root 5 into 10 raised to minus 4, which is further written as root 20 into root 5 into 10 raised to minus 2. Root 20 into root 5 is root 100 and root 100 is 10, that is 10 into 10 raised to minus 2, which can be written as 0.1 meters per second. Let's see our next quantity. Potential energy is half kx square. So let's write down the value, that is half into 10 into the value of displacement is 2 into 10 raised to minus 2 square. 2 and 10 is 5. On squaring the other term we get 5 into 4 into 10 raised to minus 4, which is 20 into 10 raised to minus 4 and can be written as 0.002 joules. And our final term, that is kinetic energy, total energy minus potential, 0.0045 minus 0.0020, which is nothing but 0.0025 joules. So that's all in this module, students. See you in the next module.